In this video, we're going to deal with rational exponents. Reminder, the word rational, root word is ratio, so we're talking about exponents that are fractions. And here's what we're going to do with exponents that are fractions. We can rewrite them. They're actually radicals. Expressions with rational exponents can be rewritten as radicals using the following rules. Exponential form, a to the 1 over n power means the nth root of a. And a to the 1 over n power can be written as the nth root of a to the first power, like that. It means the exact same thing. So a to the 1/2 power would be the square root of a. A to the m over n power is the nth root of a raised to the mth power. So the top number is a power, the bottom number is the index on your radical. So a to the m over n power is the nth root of a raised to the m power. Is how you're going to rewrite that. So let's convert between some exponential and radical forms. Each of these, again, we're going to write in radical form and simplify as needed. So x to the 1/4 power, the bottom number is the index on your radical, and the top number is your exponent. Since it's x to the first, you don't have to put it. So the 4th root of x. Next one, the 1/2 power, the bottom number is the index on your radical, so it's a 2, so that'd be a square root. And then we're going to put the top number as an exponent. Since it's a 1, you don't have to put it, and that's the square root of 15n. Number 3, 24 to the 1/3 would be the third root of 24. And that can be simplified. We can split that into the third root of 8 and the third root of 3, because the third root of 8 would be 2. So 2 times the third root of 3, simplified. Number 4, 7 to the 2/3 power. Now we're dealing with a number on top other than 1. So that'd be a third root. And then the top number is going to be an exponent. That'd be the third root of 7 squared or the third root of 49. Okay, number 5. K to the 7/2. The bottom number is the index on your radical, so it's a 2, so it's a square root. The top number is an exponent, so that's the square root of k to the 7th, and we can simplify this. We can write it as, okay, since we're doing a square root, we need multiples of 2, so we'll split into k to the 6th and k to the 1st. Square root of k to the 6th is k to the 3rd, and root k, I don't know, so it stays. Okay, number 6. 3 to the 5/4 power. The bottom number we're going to write as our index, and then the top number is going to be our power. So that's going to be the 4th root of 3 to the 5th. Now, before I multiply that out, let's do this. Let's split that. 4th roots, I want multiples of 4. So we can split this into the 4th root of 3 to the 4th and the 4th root of 3. 4th root of 3 to the 4th would be just plain 3. And then the 4th root of the 3, we're going to leave that underneath there, and that's simplified. Number 7, AB to the 3/4. The bottom number is the index. The top number is an exponent, so therefore we're going to raise AB to the 3rd power. That's how we're going to write it. And if you would like to, this can be split into and raised both to the 3rd power. That'd be the 4th root of A to the 3rd and B to the 3rd, which is not going to simplify any. Again, the bottom number is the index, so it's a 3rd root, and the top number is an exponent, so negative 6x is being raised to the 2nd power. Notice how I put it in parentheses. So that's going to be the 3rd root. Raise them both to the 2nd power would be a 36x squared. And that is not going to simplify anymore. Number 9, you have 7 times the radical, the 1/2 power is going to be written as a 2nd root, so a square root of 12w to the 1st power, so we don't have to put the 1. So let's try to clean this up. We're going to split the square root of 12 into root 4 times root 3, and the square root of w we're going to leave. So we now have 7 times 2, which would be a 14, and the other two radicals, things under the radicals, I can't simplify, so therefore we're going to leave it as is. Okay, now let's do it backwards. Let's write each in exponential form. So the index goes on the bottom of the fraction. Any kind of exponent goes on top. So this is 16 to the 1/3 power. Again, the next one, xy we're actually finding the square root of it. So it's going to be xy and a square root. That's going to be the bottom number is the root you're taking. The top number is any exponent. Both of these are being raised to the first power. So therefore xy to the 1/2 power. 8w inside the radical. We're taking the fourth root of it, and there are no exponents on it. So that'd be 8w to the 1/4 power. Number 13. Now we're dealing with an exponent and a root, so therefore we're taking the third root, so that'd be a 3 on bottom. The 11 is being raised to the second power, so that'd be 11 to the 2/3 power. This k, we're taking the fourth root of it, and we're raising it to the fifth power, so that'd be k to the 5/4 power. The 3m here. Now notice the exponents on the outside, it doesn't matter, okay? These exponents you can write on the outside, you could write on the inside around parentheses. Either way is the exact same thing. So we're taking a square root and raising it to the 7th power. So 3m to the 7/2 power. Number 16. We have a negative 2a that we're taking the fourth root of and we're raising to the 5th power. So that'd be negative 2a to the 5/4 power. Here we have all this stuff inside, 10 to the 5th, a to the 3rd, b. It's being raised to the 1/2 power because we're taking the square root of it. And then finally on number 18, 9, x to the 7th, y to the 4th. We're taking the third root. So that's going to be a third root, and then we're raising it to the first power. None of these, or this whole thing, is to a first power. There's not an extra exponent out here. Now you could divide them up individually, but for now we're going to leave like this. Now we're fixing to talk about rules of exponents, and we're going to apply those rules of exponents to this as well. Okay, now that we know how to change these, now we're actually going to simplify some expressions that have these rational exponents. Here's going to be your steps. Step number 1, we're going to rewrite all radicals in exponential form. We're going to use our rules of exponents to simplify the expressions, and then we're going to write our answers and we're going to change them back to simplest radical form and rationalize anything that we need to. Now, those rules of exponents, let's make sure that we remember x squared times x to the 3rd, you add your exponents. X squared to the 3rd power, you multiply your exponents. X to the 5th over x to the 3rd, that's when you subtract your exponents. And then, let's see, is there any other ones I'm leaving off? Anything to the 0 power is equal to 1. Oh, and one more. Anything to a negative exponent, bring it across a fraction bar, and it becomes a positive exponent. So x to the 1/3 times x to the 4/3, you're going to add these exponents is x to the 5/3. So the exact same rules apply. Then we're going to write, just for extra practice, we're going to write all of our answers back as a radical. Third root of x to the 5th. This can be simplified. We'll split it into the third root of multiples of 3 is what we need. So let's split into x to the 3rd there and x to the 2nd there. So the third root of x to the 3rd will be plain x. And then we're left with third root of x squared over there. Number 20, let me zoom in here. We're going to add our exponents together. We do need a common denominator. Multiply top and bottom by 2 gives you a 4 and a 6. So p to the 1/4 and p to the 6/4 would be p to the 7/4. Now let's write that back as a radical. The bottom number is the index. The top number is a power. Now this can be split, and the way I know it can be split before I even start, anytime this is an improper fraction, oddly enough, we'll be able to change this. So we need, since it's a fourth root, we need multiples of 4, so let's split it into p to the 4th and p to the 3rd. Fourth root of p to the 4th is plain p times the fourth root of what you're left with, which was p to the 3rd. Number 21. Anytime you're dividing, you're going to subtract your exponents. Now let's get a common denominator to see, do I have more on top or bottom? Multiply top and bottom by 2 gives me a 10 over 4. So I have p to the 10 over 4, or excuse me, m to the 10 over 4 and m to the 7 over 4. Subtract them, you're left with m to the 3 over 4. We're going to write that back as a radical. That's a fourth root of m to the 3rd power. Powers to powers, we always multiply. That's going to be multiply tops and bottoms. That's going to be a to the 5/6 power. Bottom number is an index. Top number is a power. And we can't find the 6th root of a to the 5th. The exponent's not big enough. 23, same thing, powers to powers, let's multiply. This would be 32 to the 1/4 power, which is, again, let's rewrite it as the 4th root of 32. And I think there's a 4th root in there that I know. Let's say 2 to the 4th is 16. So let's split this into the 4th root of 16 and the 4th root of 2. The 4th root of 16 is 2 times, let's leave the other one as the 4th root of 2. Next up, again, rules of exponents says that if two things are in here, there's no plus or minus sign being raised to an exponent, we can raise them both to that exponent. So we have 8 to the 2/3 and then x to the, we've got to multiply powers to powers, multiply 2 over 1 times 2 over 3, and you get x to the 4 over 3. Well, first off, 8 to the 2/3 power, when we change that, that's going to be the 3rd root of 8 to the 2nd power. Now, here's the key. Do you do the 3rd root first? Do you do 8 squared first? It does not matter. However, if you'll do a 3rd root first, you're going to be dealing with smaller numbers. So that's going to turn this into the 3rd root of 8, which is 2 to the 2nd power, which will be 4 times. Now let's do the other side. X to the 4/3 will be the 3rd root of x to the 4th. We can split that into, since it's a 3rd root, I want multiples of 3. So let's split it into x to the 3rd and the 3rd root of x to the 1st. The 3rd root of x to the 3rd is plain x, and then this other stuff stays the 3rd root of x, so I'm going to rewrite that as 4 times x, or 4x times the 3rd root of x. Number 25. Anytime you have a negative exponent, you need to make it positive before you work with it. So 100 to the negative 1/2 becomes 100 to the positive 1/2 when you move it to the bottom. Now let's write it as a radical. 1/2 power is going to be a 2nd root of 100 to the 1st power, which is now simply 1/10. Okay, you have the same base. You're going to add your exponents. 2/3 and a negative 1/3 leaves you with a 1/3. Let's change it back into a radical now. That'd be the 3rd root of 16, which I believe will simplify. I know the 3rd root of 8, so let's split it into 8 times 2. 3rd root of 8 is 2, and the 3rd root of 2 over here stays. Number 27. Anytime you have a negative exponent, again, you need a fraction bar. Let's bring it to the bottom. That's going to be negative 216. Notice the negative did not change, only the exponent. So make sure you don't change a negative out front when you move it across fraction bar, only the negative on the exponent. So now that I have on bottom, that will be the 3rd root of negative 216, which we actually know. The 3rd root of negative 216 is a negative 6. So that's finished. Anytime a fraction is being raised to a negative power, we can flip that fraction over. So that's going to be 7 over 112 to the positive 1/4 power. So that's going to be the 4th root of 7 over 112. And we could have actually reduced 7 over 112. Both of those are divisible by 7. That's 1/16. And anytime you're dealing with radicals, again, you can split radicals if it is a fraction. That's the 4th root of 1 on top and the 4th root of 16 on bottom, which is a 1 and a 2. Number 29. 3rd root of v times the square root of v. Now this one I want to go ahead and change to v to the 1/3 power times v to the 1/2 power, because you wouldn't think you can multiply a 3rd root times the square root, but actually looking at this, you can. To multiply these, you're going to have to find common denominators, which are going to be 6. So multiply top and bottom here by 2 gives you a 2 over 6. Multiply top and bottom here by 3 gives you a 3 over 6. So now you can add those exponents. 2 over 6 and 3 over 6 gives you 5 over 6. Now let's write it back as a radical. That'd be a 6th root of v to the 5th power, which will not simplify. So it is possible to multiply a cube root with a square root now. Okay, the next one, we're going to rewrite in radicals. That'd be r to the 3/4 times r to the 1/2. Okay, we need a common denominator, so we've got a 4. We need a 4 over here, so multiply top and bottom by 2. Gives you a 2 over 4. Add your exponents to be r to the 5/4 power. Since that is improper, we should be able to simplify it. Change it back, that'd be the 4th root of r to the 5th power, which we can split into the 4th root of I need multiples of 4, so we'll do r to the 4th and r to the 1st. The 4th root of r to the 4th would be plain r, and the other one stays. There's your final answer. Number 31. We have a 4 to the 1st power on top, and we have 4 to the 1/3 power on bottom. Let's clean that up. We need a common denominator. 1 over 1, multiply top and bottom by 3 gives me a 3 over 3. We can now subtract 3 over 3 on top, 1 over 3 on bottom gives me 4 to the 2/3 power, which will not simplify because, again, you don't, well, the 4s won't, but we will be able to clean it up a little bit more. So let's rewrite it. That's a 3rd root of 4 to the 2nd power, which is a 3rd root of 16. Is there any perfect cube roots in there? We know, yes, we can split into the cube root of 8 and the cube root of 2, which would be 2 times the cube root of 2. Next one on top, we have 7 to the 3/2 power when you change it over, and on bottom you have 7 to the 1/2 power. A couple of different ways you can actually do this one. When you subtract, that gives you 7 to the 2/2 or 7 to the 1st power, which is just plain 7. Another way you could have done this was written it as a large square root over both, 7 to the 3rd over 7. And that would actually, 7 to the 3rd over 7 to the 1st would be the square root of 7 to the 2nd power. And the square root of anything to the 2nd power would be 7 to the 1st power there. 33. The 4th root of x to the 10th, let's change that to x to the 10/4 power, which would be, we can reduce that. Anytime you're dealing with these, you can actually reduce your exponents. That's x to the 5/2 power. So now instead of dealing with a 4th root, you're actually dealing with a square root. So that's going to be the square root of x to the 5th, which you can write as, let's see, we can break that apart. Even powers would be x to the 4th and x to the 1st. Square root of x to the 4th would be x squared times, we're going to leave the other one under the radical, x squared times the square root of x, which looks much better than 4th roots. Next one, the 4th root of 25m squared. We can write that as 25m squared to the 1/4 power. Anytime you're raising a bunch of stuff in parentheses to a power, you can raise each one of them as long as there's no plus or minus signs. You can raise each one to that power. So you have 25 to the 1/4, and m squared to the 1/4 power would be m, let's say cross cancel, that'd be a 1 and a 2, that'd be m to the 1/2 power. 25 to the 1/4, it's going to be hard to simplify it, but here's your neat little trick. Since 25 is 5 to the 2nd power, look what you can actually do with that. 5 squared to the 1/4, and that's going to be 5 to the, when you multiply those, you get 2/4 or a half. So you can actually clean it up a little bit by doing that. And then m to the 1/2. So you have now the square root of 5, if you write it back, and the square root of m, which we can write as the square root of 5m.